Welcome to this explainer. Okay, let's just dive right in. The landscape of generative AI is shifting incredibly fast, right? We're moving from these simple back and forth chatbots to fully autonomous agents. But let's be real, there is a massive gap between running a cool little local prototype on your laptop and deploying a secure enterprise-grade production environment. So today, we're going to unpack exactly how you architect that shift, and more importantly, how you scale your AI ambitions safely using Azure AI Foundation. Here's our quick roadmap for today. We'll hit managed versus manual orchestration, built-in state and RAG, debugging and lifecycle monitoring, routing and human-in-the-loop, scaling with the control plane, and wrap up with guardrails and production security. Let's get to it. Kicking things off with Section 1, managed versus manual orchestration. This is basically the foundational architectural choice you've got to make. So before you write a single line of code, ask yourself, what are the hidden costs of building your own AI orchestration loops? Seriously, think about it. How much of your engineer's precious time is being sucked into complex plumbing, things like memory management and context window slicing, instead of them actually focusing on the brilliant agent logic that drives your business? Well, instead of juggling this messy, fragmented toolchain of separate databases and custom code environments, Azure AI Foundry steps in as a completely unified platform. It essentially removes all that heavy lifting on the back end. You get a single, cohesive environment specifically designed to help you continuously improve your generative AI models and apps without getting bogged down in the infrastructure. What's absolutely striking here is the massive workload reduction when you move away from code-heavy, manual frameworks. Like in a manual setup, you're constantly forced to hook up external databases, say Redis, just to remember a conversation. Plus, you're babysitting vulnerable API keys. But with Azure's managed agent service, all that state management is handled automatically, and security is natively baked right in. It literally frees up days, if not weeks, of developer time. Moving right along to Section 2, built-in state and RAG, let's see how this actually plays out when you sit down to develop. To abstract away all that back-end complexity we just talked about, you really only need to master 3 basic terms. Threads handle the memory. They remember the chat and manage your context window so you don't max out your tokens. Runs are the brains. They do the heavy thinking and execute the reasoning loop. And tools give your agent hands and feet. For example, giving it a code interpreter so it can write and run Python inside a secure sandbox. Now, traditionally, setting up Retrieval-Augmented Generation, or RAG, is a total headache. You've got to provision a separate vector database, write complex chunking logic, the whole shebang. But here, it's wonderfully automated. You just upload your files to the managed vector store. The agent natively handles the search, pulls the relevant chunks, and, get this, even generates accurate citations for you automatically. Let's ground this in a practical scenario. Imagine a policy concierge agent that effortlessly answers complex employee questions. It parses through these dense, heavy internal HR manuals, meaning its answers are perfectly grounded in your own secure enterprise data. And, if it needs to, it can optionally check the web for external context. All of this is completely managed within the service. Okay, Section 3, debugging and lifecycle monitoring, because let's be real, what happens when things inevitably go slightly off track and we need to peek under the hood? Here is a fundamental truth we all have to accept. Agentic flows are non-deterministic. AI models simply do not take the exact same path twice. Because of that, you can't just rely on traditional linear application logging anymore. Having crystal clear observability isn't just nice to have, it's an absolute must when your software is out there making autonomous decisions. And that is where a dedicated observability stack comes in to save the day. You can trace every single decision, every prompt, and measure tool latency. You can use built-in evaluators to constantly monitor metrics like coherence and relevance. And honestly, my favorite part, you can deploy an AI red teaming agent to proactively attack your own system, poking and prodding for vulnerabilities or jailbreaks before they ever reach your actual users. How cool is that? All right, Section 4, routing and human in the loop. Let's talk about what happens when tasks get complex and the stakes get high. So you really don't need one massive, omnipotent AI trying to do absolutely everything. Instead, you build a multi-agent system. It's like, well, actually, think of it like a corporate team. A master router agent interprets what the user wants, and then delegates the work to specialized sub-agents. One agent is your pricing expert, another translates natural language into SQL, and a third is your compliance checker. And working in this way naturally leads us to the human-in-the-loop pattern. Say your agent is about to do something big, like sending a highly sensitive email or initiating a wire transfer. It automatically enters a requires action state. It literally pauses, waits for your explicit human approval, and then, once it gets the green light, seamlessly resumes the task. It's the perfect balance of autonomy and accountability. Section 5. Scaling with the control plane. Now we're entering the realm of true fleet management, moving from a single prototype to an entire army of agents. To manage a fleet of that size, you need 100% visibility, no blind spots, and the Foundry control plane gives you exactly that. You get the ability to view and govern every single agent in your ecosystem, and that includes agents built natively in Foundry through the Microsoft framework or even using open source tools like LangChain, totally regardless of where they're hosted. Administrators basically get ultimate superpowers here. From just one single dashboard, you get a comprehensive inventory of your entire fleet. You can track real-time costs and ROI down to the individual run, enforce org-wide policies, and, crucially, if a risk is detected, you can instantly hit pause or completely disable an agent on the spot. Finally, we arrive at Section 6, Guardrails and Production Security. Because before we expose these incredibly intelligent systems to the real world, we absolutely must lock them down and ensure robust trustworthiness. You achieve this by setting up super strict, highly customized guardrails. You get to dictate exactly what risk to look out for, say data leakage or sneaky prompt injection attacks. You decide exactly where to scan for it, whether that's in the inputs, the outputs, or the tool responses. And finally, you define the automatic action to take, like blocking a harmful prompt outright before the model even processes it. Furthermore, by connecting an AI gateway, you guarantee that every single external tool your agent touches is wrapped in strict policies. And yes, that includes integrations via the new Model Context Protocol. You can restrict which IP addresses are allowed to call an API, or apply rate limiting so a super enthusiastic agent doesn't accidentally DDoS your own backend systems. But honestly, the biggest security win here is identity management. Every published agent gets its own unique Entra agent ID. By treating your agents as recognized identities within your directory, you leverage Azure role-based access control. This completely 100% eliminates the need for highly vulnerable, hard-coded API keys. Your agents are governed exactly like human employees on your network. As we wrap up this explainer, I really want you to consider the sheer maturity of these systems. With automated state management, deep observability, and ironclad governance features all natively integrated, ask yourself, is your current AI architecture truly ready for autonomous enterprise scale? Are you ready to upgrade from a handful of scripts to a governable, secure fleet? Thank you so much for joining me, and I'll catch you on the next explainer.